Hello, in this tutorial, I will be showing you how you can model refundable taxes in the Network Design app. So, for such taxes, you can have three different scenarios. This is scenario 0, where you just pay or receive money based on the difference between the debit and the credit. So, in this example, there are two plants, a CDC, two warehouses, and finally three customers. And for goods moving from plants to CDCs and CDCs to warehouses, there is a certain credit rate which you receive per product based on the product value. So in this example, there are three customers, all of which require exactly one product, and plant one will be providing 1 unit, and plant two will be providing 2 units. So there is a 1% credit rate at plant one, and the product value is 600. So that means the total credit which you get is basically the product of the the tax rate or the credit rate, the product value, and the units which will be shipped by this plant. So in this case, it's $6, whereas in this case, it is $60. And then similarly, from the CDC to the warehouses, again, you have a certain credit rate. And based on that, you can see from CDC to warehouse one, your tax credit is $60. And from CDC to warehouse two, your tax credit is $120. And then finally, when the products are being shipped from the CDCs or the warehouse to the customers, that's where you have the debit, or that's where you pay the taxes. And again, similarly, there is a tax rate, and then based on product value and the number of products that is being shipped, you have you have certain tax. So from warehouse one to customer one, that's $90. From warehouse two to customer two, that's $120. And finally, from CDC directly to the customer, that's $60. So in this example, it's very simple. The tax you pay is just the difference between all the debits minus all the credits. So as you can see, these in red are our debits, 90 plus 120 plus 60, minus all the credits that flow from in this example. So that is 60 plus 120 minus 60 plus 60. So as you can see, in the end, the tax payable is just the difference between total debit and total credit, and that is 24. However, if the credit was more than the debit, then technically you would get a negative number, which would mean that the government will pay you some additional money because it credit is more than your debit. However, in reality, if the credit is greater than the debit, that doesn't mean the government will pay you back money. Instead, all the negative credit will just directly translate to a zero. So you don't pay any tax, but you don't get any money back from the government either. And this is what scenario one is. So here, everything is the same except that the credit tax rate from plant one to CDC has increased from 1% to 10%. So now the credit you receive from here is 60 instead of 6. And when you sum the debits and the credits, as you can see, the tax payable is minus $30, which means that the government should pay you $30. But obviously, in reality, no one will pay you that. And in fact, the balance will be set to zero. And that is why you do not pay any tax, but you also do not get any money back. Therefore, the tax payable is the maximum between zero and total credit minus total debit. And here, so that means maximum of 0 and minus 30. And because 0 is greater than minus 30, the tax payable is $0. Now, I would like to discuss another scenario which exists in some countries. So, in the previous scenario, where the credit exceeded the debit, we discussed that in reality, the government will not pay you money, but instead, the excess credit will be just offset to zero. So, you do not pay any tax, but you don't get any money back. However, in some countries like Brazil, there is a policy that the excess credit will translate into debit, so you will have to pay that as tax. So the model is exactly the same as the previous one. And after summing all the credit and all the debit, we find out that the credit is excess by $30, which means that technically you should receive this money, but obviously the government will not pay you back. So in the previous scenario, this minus 30 just translates to 0 using the maximum function. However, in this scenario, the absolute value function is used instead of the maximum of 0 or total debit minus total credit. And as you can see, the absolute value function will change the minus 30 to a positive 30. So that means that you will actually have to pay the government $30 tax because your credit exceeded your debit by $30. Through these graphs, we can better understand the three scenarios which was discussed. So scenario 0 is pretty straightforward. The tax payable is total debit minus total credit. So on the y-axis is the tax payable and on the x-axis is the difference between total debit and total credit. So as you can see, if the debit is greater than the credit, then you pay a certain amount of tax. And if the credit is greater than the debit, then technically you should receive money back from the government. However, in reality, such a scenario will not exist. And instead, if the credit is greater than the debit, then it will just be offset to 0. So as you can see, if the debit is greater, then the graph will just be like this. But then the moment the credit is greater, instead of continuing like this, it just shifts to lie directly on the negative x-axis, and it means that you just pay zero tax. So the function which is used to calculate this is the maximum of 0 or 0 comma total debit minus total credit. And finally, we have scenario 2, which exists in certain countries like Brazil, where if the credit is greater than the debit, then instead of the graph continuing like this, the absolute value function will set in, and then the graph will go like this. So the greater your credit is, the greater your credit exceeds your debit, the more tax you will actually have to pay. So these are the three scenarios, and this is how their graphs look like. In this part, I would like to show you how can you actually include the refundable taxes in your model. So when you open the network design configuration wizard, you can go to step 13. And in step 13, you have the opportunity to define a new cost element. So this is where you will define the refundable taxes. So just here in the cost element, enter refundable taxes and then enable them for transportation. After creating a configuration, you will be able to generate an Excel template like this to feed in data. So if you go to the single value data sheet, you will find an attribute called custom cost, refundable taxes, refundable with limit. So if you remember previously, I showed you three different scenarios which could exist. And in your model, which scenario you would like to use can be specified here. So if you want to use scenario 0 in which you pay or receive money back based on the difference, then you have to enter 0 here. Whereas if you want to use scenario 1 in which you pay if the debit is greater than the credit, but if the credit is greater than debit and then it just offsets to 0, then you have to enter 1 here. And finally, if you want to use scenario 2 in which you also have to pay if your credit exceeds the debit, then you will have to enter 2 here. Then, in the transport cost data sheet, you can add the refundable tax per THU. So if it is a credit, you will have to add it with a minus symbol. Whereas if it's a debit, you can just leave it as a positive number. So what I did now is that in the network design app, I opened the configuration with the refundable taxes enabled, and I saved the three different scenarios as three different data sets. So right now we have scenario 0 loaded, which pertains to this situation where you either pay money or receive money back based on the difference between debit and credit, and all the costs for the refundable taxes are exactly the same as this model which we showed you. And now let's actually see what happens when we optimize this model, which is based on scenario 0. All right, so after optimization, the total refundable tax or the total tax payable comes to 24, which is exactly the same value which we discovered in this model when we manually calculated it. Now let's see what happens when you run scenario 1 in the network design app. So this is the scenario where if your debit is greater than your credit, you just pay a tax. But if your credit is greater than your debit, that does not mean that you get the money back. Instead, the balance is just offset to 0. So you don't pay any tax, but you don't get any money back either. So let's run and see what happens. So after optimizing, as you can see, the cost is 0. The cost in this case is just the refundable taxes, and it also tells us that we have an unused tax credit of 30. So this unused tax credit is basically this minus 30 in this example, which should be receivable, but that's not how it works. So that's why it is offset to 0, and that is why even in this network design app, in the end, the cost is 0. So that is scenario 1. Finally, I have loaded the dataset of scenario 2, which refers to this situation where even if the credit is greater than the debit, you then have to pay some tax because of the absolute value function. So let's see what happens when we run this model in the network design app. So as you can see, it says that we have to pay the tax of $30. And here you can see that there is a tax credit penalty, which is basically the unused tax credit, which is of $30, and that is what we have to pay. And this is exactly the result that we got in this model, which we manually calculated. As you can see, in the end, it turned out that the credit was greater than the debit by minus 30, which means that you should get the money, but obviously you will not get the money. And in places which follow this scenario, this excess credit will change into a debit because of the absolute value function. And that is why in the end, you have to pay a $30 tax. So that is why we have a 30 here. So thank you so much for watching this tutorial, and I hope that now you will be able to use refundable taxes in your model.